All right, let's go over this. Good thing the test was not today. All right. So yesterday we did the log function, and log functions. Remember, log functions have horizontal or vertical asymptotes. Vertical asymptotes. If you don't have that memorized, is there any way that you can kind of help yourself remember? Oh, okay. Yeah, good. Vertical asymptotes, logs have. While exponential functions have what type of asymptote? Yeah, horizontal. That one's not as, you kind of have to keep the E going. But these do have horizontal asymptotes. And they're inverses of each other, right? Log base E and E to the X are inverses of each other. So when you look at this fella here, you know the parent function is exponential because you have a variable in the exponent, an X, and your base is E. And of course, we said bless you when people sneeze. E is approximately what? 2.718. That's about as good as you need. So that would be exponential what? Growth or decay? Growth. Now remember, the parent function for any exponential growth is going to, of the form b to the x, is going to have two things in common, or three really. They're going to have a horizontal asymptote on the x-axis, and they're going to pass through the point 0, 1. And then the third thing in common is that they're going to be monotonic increasing, like that. So if you don't know what the base is, this could be any base greater than 1, because we're not measuring the y-axis. So we're just going to call that y equals e to the x power. Okay? So there's your starting function. So now we need to get this into standard form. Yeah, standard transformation form. Let me cut this, come down here, paste that, shrink it down. Okay. So we did this a lot already when we studied E. It just seems like maybe we've forgotten. So remember, standard transformation form, if you're interested, it's going to be like this. It's going to be, for exponentials, it's going to be A times, and then we're going to have E to the B times X minus C's power, and then plus D. So that's what it would look like specifically for an exponential function. To be inside an exponential function means to be in the exponent. So that's what we're shooting for. So the 8/3 in the front should really go in the back. That's your D value. So we get 4/5 times E. And remember, in the exponent, I'll put parentheses to kind of help group it. Step 1 is to get your X term first. So I'm going to commute it, but notice it's still a negative 2/7. And then we have a plus 8/3 right here. And now, the fun part, we have to factor out the coefficient of X in the inside. So it will remain in the exponent. And of course, the coefficient is negative 2/7. So when I factor a negative 2/7 out, I'm going to be left with the quantity X. And then, of course, I know the sign's going to change, minus, but the question is what remains? Well, we said you could do it off to the side. When you factor out, you divide out. So we are dividing out a 2/7 from 2. So that's 2 divided by 2/7. And so we could do stay, change, flip, right? Stay, change, flip. And then you could put that over 1. And then what happens with the 2's? They divide out, and you're left with 7. Now notice I have 2 closed parentheses because I opened 2. I got to close 2. If you quickly redistribute, it doesn't take long, mentally redistribute, see if you get a plus 2. Negative 2/7 times negative 7 is positive. The 7's divide out, and you're left with 2. So you know that's correct. All right, so real quickly, let's just talk about it. I'm not going to write them down, but going from left to right, describing the transformations. The 4/5 in front multiplied will be a vertical what? Compression by a factor of 5/4. Excellent. The negative in front of the 2/7 is a reflection across the y-axis. The 2/7 is a horizontal stretch. Good. Opposite of what you would think. It's a horizontal stretch by a factor of 7/2. Great. And then the boring ones, the -7, and we pick the graph up and shift it right 7. And then perhaps the most critical shift, the plus 8/3 means we pick the graph up and move it up 8/3. Okay. Now why is up 8/3 important? the only transformation that is going to seriously affect the horizontal asymptote is a vertical shift, right? So if you remember from the exponential days, you're going to have a horizontal asymptote at y equals whatever your d value is from your standard transformation form. So we know we're going to have a horizontal asymptote at y equals 8/3. So let's go ahead and see what the shape is. Remember, we don't have to worry about the dilations, but the reflections are super important. And y'all told me it was a reflection across the y-axis. So if I take my e to the x and I reflect it across the y-axis, it's going to look something like that. And that's really the only reflection I have. So that's my final shape. My final shape should be a decreasing function above the horizontal asymptote, right? What would make it go below the horizontal asymptote? Reflection across the x-axis. Okay, good. So I think I'm ready to, I need to go in order here. B, find the simplified exact y-intercept. So this takes care of A. That's standard transformation form. I have you find the y-intercept first just to help you with your sketching. So remember, you're communicating that tomorrow on the test by doing f of 0. It's probably easier to plug it into the original version. Again, the standard transformation form would work, but it's best suited for graphing purposes. So if you plug in a 0, you're going to get 8/3 plus 4/5 times e to the 2th power, 2 minus 0. Is that a positive or a negative number? It's positive, okay? Because e is around 3. 3 squared is around 9. 9 times a positive fraction is positive, plus a positive 8/3 is positive. So we know that's greater than 0. You don't have to put greater than 0, but you should know that it's greater than 0. Okay, cool. So part C is to sketch it. The first step in creating a sketch is to give yourself a set of axes. So I'll just draw x and y axes. Now, anytime you have a vertical asymptote or a horizontal asymptote or a slant asymptote, whatever the case may be, you want to sketch it first. Even though that's the last thing we do in our transformation, shift it up 8/3, you want to sketch the asymptote first because it becomes a guideline for the rest of the graph. So if we shift it up 8/3, you don't have to count to 8/3. Just put a mark and call it 8/3. I'm happy with that. And so now we'll draw a dotted or a dashed line, whatever you prefer, whether you want to call it dashed or dashed. Oh, cool dude, still live. All right. And now it's decreasing above. So notice in this case, there was no question about whether it crossed the y-axis in positive or negative land, correct? Because it has to cross in positive land because it lives above the horizontal asymptote that was shifted up, okay? So really, when it comes to the graph, that's pretty much all you have to show. Your horizontal asymptote is labeled. You have arrows on the end. It's decreasing, approaching the horizontal asymptote. You don't really even have to label the y-intercept because I didn't ask you to. But if you wanted to, it would be 0, comma, and then it would be the fantastic number 8/3 plus 4/5 e squared. That just kind of clutters up the graph. Okay, so now that we have the graph done, we can answer the rest of the questions. Part D and E, find the domain and range. So the domain of F and E, the range of F. Now remember, the domain we can always get algebraically. We're trying to avoid division by 0. We have no denominator. We can only take logs of positive numbers. We don't have logs. And we can only take square roots of non-negatives, 0 or positive. We don't have square roots. So unless it's a piecewise function, which this is not, and it passes those 3 hurdles, the domain is going to be all real numbers. And you can tell from the graph that it in fact is, right? It runs east to west forever. Now that's important because the inverse of E is natural log, and the domain of all real numbers for E becomes the range of all real numbers for Ln, right? The X and Y information switch. In fact, if you notice over here, E had a y-intercept at 0, 1, while the natural log of X would have an x-intercept at, flip the X and Y's, 1, 0. They're inverses of each other. Okay, now the range we typically get from the graph. So here's where all of your hard work will pay off. What is the range? Look at your graph. Everything what? Yeah, good. So it's the set of all y, we can say, such that y is strictly greater, not greater than or equal to, strictly greater than 8/3, Or, of course, if you're the interval notation person, you could say 8/3, comma, to infinity with parentheses around both. Okay, and then what else? What else? Find the equation of any asymptotes. All right, so we do have one. We need to say which type. So part F, we have a horizontal asymptote, and you could call it ha, at what? Y equals, good, Y equals 8/3. So if you're missing any of those three things, the HA, the Y, or the 8/3, you're not going to get credit. So don't just say horizontal asymptote at 8/3. Don't just say Y equals 8/3. Say HA at, and you can use the at symbol or write the word at, and then Y equals for horizontal, X equals for vertical. And then the last part, what is the limit as X goes to infinity? I'll write that, EFG. The limit as X goes to infinity of F of X is what? Yeah, 8/3. Now for log questions, I can only ask one end behavior. Logs only have one end. They either live to the right of the VA or to the left of the VA. But exponentials run east to west forever, so I could also ask, just as likely to ask this question: what would be the limit as X goes to negative infinity? Positive infinity. As you go to the left, it goes to the positive infinity. Or, of course, Zach, good morning. B and E on a free response would also work. Okay, there you go. Any questions on that one? If that's a free response question tomorrow, everyone's getting all 9 checks, right? I hope. All right, so you know exactly what your free response question will be, kind of. It's either going to be like the one we did yesterday, which was this one, a log, okay, or it's going to be an exponential E, like the one we just did. One of those. And I'll ask the same types of questions. It'll pretty much be the same sequence, okay? So hopefully the fractions now that you see aren't freaking you out. The thing that you need to be most careful about, remember, is up here in the exponent, right? In the inside of the function, whether it's the argument of the log or the exponent. You need your x term to be first, and then you factor out the coefficient. And again, if you're not sure what's left, go off to the side and divide it out. Put your answer, and then mentally check before you proceed by distributing it back through. Catch a careless mistake. All right, there's half your test for tomorrow. Any other questions or comments about it? All right. It's International Ninja Day. Bless you. So just take about a second and turn to your left or right or below you or above you and say hi to the ninja that's hanging out with us today. Hello, ninja. All right. I hope he heard that. I know he did. Okay, cool. Getting back to the notes then, we are on example, we skipped to example 7, and we did example A, B, and C. So let's go ahead and jump to, I don't know, what comes after C? Letter D is the immediate follower, but lots of letters follow C, right? C is a great leader. That's why lots of things follow C. Who's a better leader than C? B is better, but A is the best because the most things follow A. Yeah, cool. Right, okay, and the drum kit falls to the ground. Okay, so we're trying to solve for X. What do you notice here? How many logs do we have? 3. We have 3 logs. We need to be able to condense. Notice your arguments on the left are linear, and the argument on the right is linear. 3x minus 2, 1x minus 1, 1x plus 0, or just x. So what did we do yesterday? How did we get 2 logs into 1 log? Condense. All right, the coefficients are already 1 and -1, or both positive 1, so there's nothing to bring up, so we can go straight to condensing this side. It's the natural log of. What do we do with the arguments? We multiply them, right? So 3x minus 2 times x minus 1. Easy. Now on the right side, we can bring the 2 up on the x, and that becomes the natural log of x squared. Now notice, right here, you're kind of on a red flag alert, as well as maybe right here, because you had linear arguments, x to the first, But now I have a quadratic argument, and as soon as I expand this, I'm going to have another quadratic. So what's the red flag on the lookout for? Extraneous solutions, yeah. All right, now, from here, you have log equals log. You've isolated the logs on both sides. So mathematically, if you wanted to unnatural log something, how do you do that? Exponentiate it base e. You can e both sides like that, and you end up with just 3x minus 2 times x minus 1 equaling x squared. Okay, so that's one way to do it. Or you can use what we call, again, the GT-BTS method. It basically says if b to the x equals b to the y, then x equals y, because exponentials are 1 to 1. But it also works for logs. If you have log base b of x equaling log base b of y, you can also equate the arguments, because logs are also 1 to 1. So however you want to get to this line that we're at right now, just drop the logs from both sides or e both sides. Either way works. But notice you can't drop the logs in the first step because you have two terms. It only works if you have log equals log, okay? All right, so now we're back in Algebra 2. To solve this, I need to expand everything out, collect like terms. So if I distribute or FOIL, I get 3x squared minus 3x minus 2x plus 2, and then red rover, let x squared come over. Man, that's a fun game. And now it's equal to 0. Now we'll collect like terms. I've got a 3x squared minus a 1x squared. That leaves me 2x squared. I've got a minus 3x, a minus 2x. That's minus 5x. And then I've got a lone wolf of plus 2, which I guess is 2 wolves. Not really lone at all. Okay. Now it's equal to 0. We have a trinomial, quadratic trinomial, equal to 0. What do we attempt to do? F it. Factor it. And if it doesn't factor it, we still can either complete the square or use the quadratic formula or hope and pray, right? So 2 is prime, so it's got to be a 2x and a 1x. And as I already mentioned in the back, the constant, 2 is prime. So it's going to be one of two things. It's either going to be the 2-1 combo or the 1-2 combo. I think it's going to be the old 1-2 combo. The old 1-2 combo. And so that's going to give me a negative, right? So hopefully factoring is not the obstacle now to success. If it is, come see me, and I'll give you like 300 factor problems to do for homework. What? Yeah, right. That kind of seems like punishment, right? Maybe I'll give you only 200. All right, so just check it. If you factor it, just quickly FOIL it out. On the outside, you can get minus 4x. On the inside, minus x. That gives you negative 5x, good. And then negative 1 times negative 2 for the last gives you the positive 2. So that's good. Now from here, you can either physically set them each equal to 0 and then algebraically solve, or you can just look at the roots and tell me what the roots are, or look at the factors, and tell me what the roots are. What's the root of 2x minus 1? 1/2, good. So you set it equal to 0 in your head, mentally bring the 1 across, divide by 2. And then this one's a little bit easier. It's 2. Now, we were putting a lot of x values into boxes yesterday and shipping them off as Christmas gifts. But we did ship off one that had a dead cat in it. Okay? So let's see if we can avoid doing that today. Right, we did have holes in the box. Which helped the other cat that was in there that was still alive. Do we want both of these? Do they both work? What should we do? Check. So you check by plugging it all the way back up here in the original. And really the only thing we're looking for is, we don't have to see if we plug it in and get a true statement. We'll trust our math on that. We're only checking to see that when we plug it into the argument and evaluate the argument, we end up with what type of number? Positive. Okay, so let's plug in the 1/2 and see. 3 times 1/2 is 3/2. 3/2 is 1.5, yeah? What's 1.5 minus 2? Negative. Who cares? Okay, cool. It has to work in all three. It didn't even work in the first one, so there's the dead cat. And then 2, let's see if 2 works. 3 times 2 is 6. 6 minus 2 is positive. Who cares? Yeah. 2 minus 1 is positive. Who cares? And over here, you plug in a 2 for x and you get positive. Who cares? So the 2 works. Okay. So really on a test, you can just stop right there. You don't have to box anything up. If you leave the 2 visible as your solution, I know that's the one you want. I do want to see the 1/2 though, and either one line or an X through it like that. So again, don't obliterate it. I need to see underneath there that there still is a 1/2. All right, there you go. So you get in the habit of checking your answers. Now that's not the only way to do it. You could have brought this 2 ln of x over to the left side, had it equal to 0, and then condensed. It would have worked out the same way. But in general, if you can get 1 log on one side and 1 log on the other, then you can drop the logs if they're the same pace. Okay? All right, any questions or comments on that one? We have 13 minutes left. That's a lucky number. Letter E. Today's a federal holiday, by the way. Did you know that? Yeah, it's a mandated federal holiday. So you won't be getting mail today. U.S. Postal Service is shut down. It is actually a federal holiday in honor of H.W. Bush's funeral today. So it's a federal holiday, though. A federal day of mourning. Yeah, that's right. They don't have to go to work today, the federal employees. So call it what you want. I doubt every single federal employee that's off today is going to be just sitting at home mourning, right? Some of them are going to probably go sleep in, go to Top Golf, whatever. So, yeah. But, yeah, anyway. Letter E, log base 2 plus log base 2 equals log base 2. All right, let's do this one quickly. We need to get log equals log, log equals log. So we need to condense the left side. So that's log base 2 of, what do we do with the 2 arguments? Multiply them because they both come from positive terms. So that's x times 3x squared. On the right side, it's already good to go, like a Crunchwrap Supreme from Taco Bell, right? Good to go. Now I got log base 2 equals log base 2. What can I do with the log base 2s? Take them out. I can drop them. Now, if you drop them by the theorem, you want to say, so 3x cubed equals 24. If you don't want to say so by use of the theorem, then algebraically you need to show me that you're exponentiating both sides base 2. Okay? So anytime it's a result of a theorem, it's like therefore or ergo or consequently, whatever, you get that. All right, so now we just have to solve for x cubed. So what do? Take the cube root of both sides? Ah, good. You want to isolate the x cubed. 3 is not a perfect cube, so I wouldn't do that. So let's isolate the x cubed, divide both sides by 3, 24 thirds is 8. Now we'll take the cube root of both sides. Plus or minus 2 or just 2? Right. When do we do plus or minus? Square root or not just positive, because 3 is a positive root, but it's an odd root. So square root, 4th root, 6th root, 8th root, even roots, right? If you ever take the eventh root or raise something to the 1 over an eventh power, that's when you consider plus or minus. It's the only answer that we got, so must it work? No, there's no guarantee that it's going to work. Let's plug it in. You plug in a 2 right here for x and you get positive, who cares? Plug in a 2 right here and you get 2 squared is 4 times 3 is positive, who cares? And then plug in a 2 there and it's like, I don't need you to plug in, I'm already at 24. And you're like, okay, sorry, dude. So, does this work? Yeah, it works. So, you're done. There you go. All right, fun. We got 10 minutes left. We got for the ninja. All right. I was choked. I read this one while I was drinking. That was a mistake. What do you notice about this one? Oh, yeah. What's that, George? Perfect, man. Perfect. You're not just telling me what the problem is. You're telling me the solution. That's a good person. Somebody just walks in and just whines, and the bases aren't the same. No one wants to hear that. How about the bases aren't the same? I propose we use the change of base formula. That's a solution. All right. So we can't condense if the bases aren't the same. So we do have to get the bases the same. So I wrote the 10 there. We have 2 options. We can write, or 3 actually. We can write them both in terms of base 100. We can write them both in terms of base 10. Or we can elect to write them both in terms of some third-party base. Natural log. Very good. When in doubt, natural log. So let's do that. We're going to get the natural log of x squared over the natural log of 100 minus the natural log of x cubed over the natural log of 10 equals the natural log of 6. Yes, yes? All right, good. George is on fire today. There's no natural log on the right-hand side. He doesn't know where I got that. I pulled it out of my donkey, right? Mm-hmm. I have a little, yeah, don't think where I pulled it out of the donkey. My donkey has a saddle pack with pouches, and I keep natural logs in there. Yeah. Mm-hmm. Okay, so we only used the change of base formula on the left. We didn't take the natural log of both sides, so the right side's still 6. Okay, that's looking a whole lot better, isn't it? I don't think so. So let's see what we can do. Hey, the natural log of 100 and the natural log of 10, those are just what? Are they numbers or variables? They're just numbers, right? So let's do this. Dividing by a number is the same as multiplying by 1 over that number. What's another name for 100? 10 squared, right? Or señor ciento, right? 10 squared. Where does that 2 go then, if we can write it like that? To the front. Let's just put it there. So the natural log of 100 is also known as 2 natural log of 10. So I'm going to pull that out front, and now we get the natural log of x squared. Good. We'll do the same thing over here. We get 1 over the natural log of 10 times the natural log of x cubed equals 6. Oh, boy. Okay. How does that help? Do I have a common factor? No. Close. Natural log of 10 in the denominator. Let's factor out a 1 over natural log of 10. Simplify early and often. That leaves us a 1/2 natural log of x squared minus natural log of x cubed equals 6. Okay, that's better. So now I just have some number out front. And this makes it easier to work with now inside the parentheses. Before I can condense those ln's, what must I do with this 1/2? I need to bring it back up as an exponent. I could have, up on the previous line, I could have brought that whole thing up, but yucky, yucky, gross, gross, right? So by factoring out the 1 over ln of 10, I get the yucky, yucky, gross part out front. Okay, so I factor that out. Now, I still have to keep writing 1 over ln of 10. If I bring up the 1/2 on the 2, what do I do with the 2 and the 1/2? Multiply. What's 2 times 1/2? 1, right? So I can just get x to the first minus the natural log of x cubed. All right, I think now we're ready to go. We get 1 over natural log of 10. I can now condense that. Pulling out 1 natural log, I have at least 1 negative term. So what goes in the top? Just the argument of the positive term, x. What goes in the denominator? X cubed. Good. And that's equal to 6. And 6 is like over here, like, hurry up, left side. This is boring. I didn't have to pee before this problem started, but now I do. You're taking your old sweet time. 6. Okay. That's just to simulate waiting. That's time ticking. I don't know. Oh, yeah. Pee on Chevy. Oh, great. Put that on the back of your car. That makes a statement. Okay. All right. So what is x over x cubed? Simplify to. X to the negative second, or 1 over x squared. I'll call it x to the negative 2 power. Why the heck not? Okay. That equals 6. Okay. Are we even making progress? Geesh, I don't know. What should I do now? Anyone help? Anyone? Well, that's why I'm asking leading questions. No, what have we been doing? We've been isolating the log, right? How do I isolate the natural log? Yeah, multiply both sides by reciprocal. Whew. Okay, so I get ln to the negative 2 equals 6 natural log of 10. Oh, by the way, could I have brought that 2 out, the negative 2 out front? Actually, I could have. But that would make my argument linear. And notice my argument started off being a quadratic. That's dangerous if you go that direction. If it starts as a quadratic, you can have up to 2 solutions. If you turn it into linear, now you can lose a solution. So I'm going to leave it like that. All right, so now let's come over here. Let's clean this up a little bit, kind of dry off some of that pee. There we go. Now I can convert it. What can I do to both sides? That's right. I can unnatural log it by e-ing it. That's hard to say. By e-ing it, not peeing it, e-ing it. E-ing it. So on the left side, e to the natural log of blob is blob. Okay? So that's 1 over x squared, or x to the negative 2. And on the right, I get e to the 6th natural log of 10th power. Okay, sweet. Bless you. We're almost there. So I get 1 over x squared equals. What's e to the 6th natural log of 10? Is that anything? No, but guess what I could do in the exponent with the 6? Move it back up as an exponent. That's e to the natural log of 10 to the 6th power. And now I have 1 over x squared equals, what's e to the natural log of blob? The blob. Yep. Yep. Hey, I'm going to call 1 over x squared x to the negative 2. I like that. Okay. Now, last step. How do I solve for x? I raise both sides to the reciprocal power. And when I raise both sides to a reciprocal power, anything times its reciprocal is 1. But I end up with 10 to the 6 times negative half is negative 3. What did I just tell you you must do when you take the eventh root, square root, fourth root of both sides of an equation? Plus or minus. It didn't look like we were taking the square root, but we were raising both sides to the 1 over an even number power. So you got to do plus or minus. Okay, so now your final answer is x equals negative 1 over 1,000. That's what 10 cubed is. Or x equals positive 1 over 1,000. Boy, that's not the only way to do the problem, but that is certainly one way. If we plugged it back up here, let's see if it works. If I plug in a negative number here and square it, it's going to be positive, right? But what happens if I plugged in the negative version here? What's a negative number cubed? Negative. So what can I say about the negative one? And this is the only answer. 1/1000th. Go gadget math. All right. Test tomorrow. You know what your free response is? I will just tell you here at the very end, if you want to work a practice test, the practice test that's worth working is the only one that's on there that covers that whole section. Okay? So I'll pull this up right here, and I'll be here in the morning for tutorials if you have any questions. 4.1 through 4.5, right here, the 2014 test. All right, the 2014 test. Everyone see that? There's only one from 4.1 to 4.5. Forget about the free response, though, because it's different. You know what it's going to be, but the multiple choice on here, that's good to prepare, okay? I had that in front of me when I made the test. Have a great day.